All right, let's talk about what happens in an equation when something kind of odd happens with your variables. So these are called special equations. So let me give you just kind of, let's talk about an easy, simple one first to kind of lay the groundwork. If I give you a problem like x plus 5 equals 8, okay? If I solve this algebraically, very simply, we get x equals 3, okay? That's your answer, super easy. What that is telling you is that 3 is the only number that you can plug back in, and 3 plus 5 will equal 8. Okay, that's the only option that works in this example. All right, if we look at a slightly more complicated one, x plus 5 equals 3x minus 1. Okay, if I solve this pretty quickly, this should be getting pretty automatic by now. I'm going to move my variables together, always move the smaller one. So I end up with 5 equals 2x minus 1. And then going through these steps pretty quick, I'm going to add 1 to both sides. 6 equals 2x. Divide by 2 on both sides, and you get 3 equals x on this problem. This one is a little bit trickier to see. Obviously over here, 3 plus 5 made 8. But on this one, what you're getting into is, okay, if I plug in a 3 for both of these x's, I get 3 plus 5 would make 8. And 3 times 3 is 9, minus 1 would make 8. Okay, it's the only value that I can plug in that makes one side of the equation equal the other side of the equation. Pretty simple. You're isolating the variable, you're getting a number value left for what that is actually worth, okay? So let's look at what happens in a really weird situation. We're gonna start out very, very simple, okay? So let's start out with x plus 5 equals x plus 5, okay? The question is, what is the number for x that will make the left side of the equation equal the right side of the equation? If I do this algebraically, I end up with 5 equals, those also cancel out, 5, okay? So it kind of makes sense if you look at this first part. No matter what you plug in for x, if you add 5 to it, and then over here you take that same number and add 5 to it, these are always going to end up equaling each other, okay? X could be 3. 3 plus 5 would equal 3 plus 5 if I plug in a 3 for both of those. X could also be negative 7. Negative 7 plus 5 is going to equal negative 7 plus 5. So I'm just picking a random number and proving that here I've got two different values that are making this equal each other, okay? That wasn't happening up in those first examples. There was only one number that would work, okay? So when this happens, we call this all real numbers would be your solution. Don't get hung up on this word real. For right now, just know that that's part of how you describe the numbers, because yes, there are imaginary numbers. We're not gonna get into it, okay? The other symbol that you'll see sometimes is you might see that funky looking capital R. I know Photomath kind of does a little bit of it has some weird curly Q things happening in it. But basically they both mean that X could be anything for this equation. There's not just one straight answer like what we've seen in the past. There's a ton of them. This one was pretty obvious, right? The same exact expression on both sides is obviously always going to be equal no matter what we plug in. Where it gets tricky is when we start seeing slightly more complicated ones like 3x plus 8 equals negative 3x plus 2 parentheses 4 plus 3x. Yeah, I said slightly more complicated. Maybe that was a lie. Okay, the left-hand side is pretty simple, so I can't really do anything with it. But on the right-hand side, I'm going to distribute first. So I'm going to get 8 plus 6x, and then my negative 3x is going to pull straight down. Here I can still continue to combine that negative 3 and that positive 6. which would make 3x plus 8 and 3x plus 8. So at this point, you should kind of recognize, hey, that's the same exact thing on both sides. It's always going to equal each other. But if I just am going through my algebra steps, I'm going to subtract 3x to move them together. And this is where you're going to see, wait a minute, it cancels out on both sides, and all I'm left with is 8 equals 8. Well, 8 always equals 8, no matter what x is. 8 is the same as 8. So this is your all real numbers, or you can actually write it out, okay? If I'm feeling a little more writing. So this is your answer, okay? Your answer is not the 5 equals, oh, sorry. This is your answer, not the 5 equals 5, not the 8 equals 8. The 8 equals 8 is just assigned to you to say, hey, that means this always works. No matter what x is, it always works, okay? So that's what all real numbers looks like. If they end up with the same exact expression on both sides of the equal sign, and they end up canceling out, all of your variables disappear. On the flip side, you can also have problems like x plus 5 equals x minus 2. Okay, if I'm just thinking algebra and I'm not using any common sense whatsoever, I would subtract x from both sides to move my x's together. Here I see that they both cancel out. X's are completely gone, and I'm left with 5 equals negative 2. 5 doesn't equal negative 2. It never will. No matter what I plug in for x, there's not a single number that will make the same result by adding 5 to it and subtracting 2. Okay? I can test it out here. If I test out, a lot of times people think 0 will work, so let's see if 0 works. 0 plus 5 and 0 minus 2, well, that would make 5, and that would make negative 2, so that does not work. Sometimes people think, well, what if I did 2 minus 2? Well, if I'm plugging in a 2 here, I'm also going to plug in a 2 here. Here I end up with 7 and 0, so those don't match, okay? So when you get a situation like that, now we're going to say there's no solution. There is not a single number that you can think of, and you can spend hours working on it if you don't have anything else better in your life to do. You could keep plugging numbers in. There's no number in the world that you can add 5 to it, and then you can subtract 2, and they end up at the same ending location. Doesn't happen. It's not possible, okay? So if you get, x plus 5 and x minus 2, they're never going to match each other. Again, sometimes that looks a little more complicated. So 4 parentheses 1 minus 2x close parentheses equals negative 2x plus 3 minus 6x. All right. Feel free to pause it if you want to give it a shot on this. I'm going to distribute and get 4 minus 8x. I just distributed 4 times 1 and 4 times negative 2x. Over here I don't have any distributing, but I can combine negative 2x and negative 6x, which makes negative 8x plus 3. So if you kind of start looking here, I've got negative 8x with a positive 4, negative 8x with a positive 3. Doesn't seem like this is going to ever match. If I just go straight algebra on this, I would add 8 to move it. They cancel out, and I'm left with a 4. I add 8 on this side. They also cancel out, and I'm left with a 3. Well, 4 doesn't equal 3, ever, never, no matter what. So that makes this a no solution answer. Okay? Now, here's the catch. This is only, and I'm going to write this kind of in all caps, this is only when all variables cancel out. If your problem still has variables in it, then this is not a special situation, okay? This is a big deal, this, only when your variables disappear. Because here's where we get confused, is if I give you a problem like 3, parentheses x plus 4, close parentheses, equals negative 3 plus 12. Oh, sorry, negative 3x plus 12, okay? If I simplify the left side, I get 3x plus 12. If I simplify the right side, I get negative 3x plus 12. And you might be tempted to think that this is either always going to match or never going to match because they look very similar, but they are a little bit different. So hopefully we see, hey, it's probably not this situation because it doesn't match perfectly, okay? So let's see what happens here. If I'm going to move my variables together, I'm always going to move the smaller one. So if I move negative 3x, I'm going to add 3x so that that cancels out. If I added 3x on the right, we're going to add 3x on the left. And you end up with 6x plus 12 equals 12. We subtract the 12 to finish out my steps. Those are going to cancel out, and I get 6x equals, those also cancel out, but it's not variables canceling out. So I'm going to put a 0 down. 12 minus 12 is 0. To finish solving this, I'm going to divide by 6. Well, how many 6's go into 0? That answer is 0. So that one is actually not special, okay? I know that's weird because you end up with a 0, which we don't typically see in a problem, but you still have a variable. As long as there's still variables in the problem, it's not out of the picture yet. All right, I'm going to give you a challenge question. Try and do this one. And maybe, I don't know, if you bring it to me solved on Friday, maybe there will be a bonus in there. Negative 7x plus 4 minus 3x equals 3 minus 5 parentheses 2x plus 1. Whoops, and then there's your close parentheses. So pause that. Here, I'll zoom in on it a little bit so you can kind of see what our problem looks like. Give that one a shot, and we'll talk about it when I see you again.